morning, girls. Welcome to your chemistry class. Today we shall begin a new chapter, chemical changes and reactions. I hope you have finished your assignment of the previous chapter. Right. So today let us begin with this new chapter, that is chemical changes and reactions. Now, what is a chemical reaction? The first thing that we need to understand in this chapter is what is a chemical reaction? What is a chemical reaction? Okay, many of you must be knowing we generally write down the reactions, but you actually do not know how to define that chemical reaction. So today I am going to make you first understand what is a chemical reaction. So write down, it is a chemical reaction is a chemical change. Okay, it is a chemical change in which matter changes into a new substance. Okay, what did I say? What is a chemical reaction? Chemical reaction is a chemical change in which matter changes into a new substance. In a chemical reaction, the substance that takes part in the reaction is called as a reactant, and the new substance that is formed, that is called as a product. Let me give you an example over here, like N2 plus O2. It gives us 2NO. Clear? So what is this? They are the reactants. They are called as the reactants. The arrow shows in which direction the reaction proceeds, and this is the product. Okay? So this is a chemical reaction. It is a chemical change in which matter changes into a new substance. I hope this is very clear. Now, what is the procedure of this chemical reaction? How do these chemical reactions takes place? So this is what I am going to explain you next. So during a chemical reaction, you know what happens? The bonds of the reactants, they break. Now, how do the bonds break? So how is this nitrogen molecule forming a bond? Nitrogen combines with another atom of nitrogen with 3 bonds. Okay, this is combining with oxygen, which is bonded with another type of oxygen with double bond. So over here the bond breaks. The bond breaks, and again what happens? Results into a new kind of bonds that are formed. What are the new kind of bonds that will be formed between N and O? These kind of 2 new bonds will be formed. 2 new bonds will be formed. What happened in the reactant? When these reactants were brought, due to heat, the bonds they broke, and rearrangement of these bond took place, and new arrangement of bond was formed, forming the new products. Is this clear to all? Okay, you must have heard number of times I am using this word bond. What do we mean by this word bond? Right? These bonds, they are the linkages. Okay? They are the linkages or the forces, or we can also say that they are the forces between the 2 atoms, okay, to hold them together, to form a molecule. Okay, so due to this bond, see earlier before the reaction proceeded, there was a bond between this nitrogen atom and this nitrogen atom. So these are the linkages, or there is some force of attraction between these 2 atoms, which has held them together. There is some force of attraction between these two. But when these two molecules, they are brought together and they are heated. So what happens? The bond, they break. And when the bonds, they break, rearrangement of the bond takes place in a new form. And those new form are called as your products. I hope this chemical reaction is very clear to all of you. Right. Now, in this chapter, we are further going to understand today the characteristics of these chemical reactions. So, today's video, we are going to study about the characteristics of the chemical reactions. Characteristics. Characteristics of chemical reactions. So basically there are 4 characteristics of a chemical reaction. What are those 4 characteristics of a chemical reaction? Firstly, change in color. Okay. The first kind is change in color. The second is evolution of gas. The third is formation of a precipitate. Okay, PPT stands for precipitate, and the last of it is the evolution of or absorption of heat. Evolution or absorption of heat. So these are the 4 characteristics of a chemical reaction. That I mean to say that whatever reactions you study, you will either find there is change in the color, or there is evolution of gas, or maybe there is a formation of a PPT, or maybe evolution or absorption of heat. So these are some of the characteristics of a chemical reaction, where we are going to begin with the first kind, that is change in color. So let us first understand change in color. The first one, change in color. Now observe some reactions over here very carefully, because this particular chapter is completely based on reactions. So change in color, let us take these reactions like copper nitrate. Okay, copper nitrate, if you heat, this copper nitrate is blue in color. When you heat, it gives you copper oxide plus nitrogen dioxide plus oxygen gas. So this blue color copper nitrate changes to black color copper oxide. So change in color took place, the blue color vanished. Okay, and a new substance is formed, that is of black color, and a reddish brown gas was evolved. A reddish brown gas was also evolved. This is a colorless gas also was given out. Colorless gas was also given out. So basically, if you are talking about substances that is left behind, so earlier before the reaction began, the copper nitrate was of blue color. Once when you heat it, it changed to black color and some reddish brown gas was given out. Clear? So there was a change in color. Take another example like PbNO3 whole twice. This is a white substance. It's a white powder. It's a white powder. When you heat this white powder, it gives you lead monoxide, which is yellow in color. Also called as litharge. Another name of this PbO, the color that it gives out, yellow color, is the litharge. Clear? And what else it is going to give you? Nitrogen dioxide gas. What is the color of nitrogen dioxide gas? Reddish brown gas plus oxygen gas, that is colorless gas, is given out. So I hope this first point is clear to all of you. Change in color. The reactant on heating changes its color. Okay, so this is one of the characteristic of chemical reactions, that the reactants, they change their color on heating. Okay, next we move to second kind. What was the second kind we had studied? Okay, evolution of gas. So let us study about the second one. Evolution of gas. Okay, let me write it down again. Second one, evolution of gas. So let's take few examples. Just now I gave you one example, copper nitrate. Do you remember? On heating, what does it give? Copper oxide plus evolution of gas, NO2, reddish brown fumes. Reddish brown fumes or gas was given out, and oxygen gas is given out. Evolution of gas is given. Another example, we can take Na2SO3, sodium sulfite. When it is treated with dilute sulfuric acid. When it is treated with dilute sulfuric acid, what is it going to form? It will form Na2SO4 plus SO2 plus H2O. So here sulfur dioxide gas is given out. Similarly, we can take another example like calcium carbonate when treated with hydrogen chloride, which is also dilute, right? When this is heated, what is it going to give us? Calcium chloride plus, it's a carbonate this side, so carbon dioxide will be given out, okay, plus water will be formed over here. So what do you observe over here? This is a colorless gas, no doubt, but we observe brisk effervescence over here, okay. With sulfur dioxide, it shows it smells like a burning sulfur. Burning sulfur. Okay. Sulfur dioxide gas. How can we identify the sulfur dioxide gas? By smelling the burning sulfur. Another example you can take like NH4Cl when treated with calcium hydroxide. Okay. When this is treated with calcium hydroxide, it will give you CaCl2 plus H2O plus NH3. This gas is a pungent smelling gas. This is a pungent smelling gas. Clear? So many reactions I showed you where there was evolution of gas. This way there are several other kind of reactions where you will find evolution of gas. Let's take one more example. Magnesium, when it is dropped in HCl, what is it going to give us? Magnesium chloride plus a colorless, odorless gas, that is hydrogen gas, is given out. Okay. Then this also shows brisk effervescence. Then another example could be like, if I take Pb3O4, okay, and heat it, what it is going to give us? It will give us PbO plus O2, another colorless gas which rekindles a burning splinter. So many reactions I have shown you where one of the characteristics of the equation is what? Chemical reaction is what? Evolution of gas. Most of the reactions you will find evolution of gas. So that is one of the characteristics of a chemical reaction. We come to the third kind. The third kind was what? The third one was formation Formation of precipitate. Formation of precipitate. Now, firstly we need to understand what is a precipitate. In short, it is termed as PPT, where small p and T, not capital P's. Remember, small p's and T. They are insoluble substances. After reaction, the product which is formed, which is insoluble in water, they are termed as PPTs, and they are always shown by downward arrow. Gases are shown by the upward arrow and PPTs are shown by the downward arrow. Clear? So let us take few examples over here also, like say lead nitrate. Okay, when this is treated with NaCl, so what it is going to form? It will form PbCl2, which is a precipitate, plus NaNO3. Okay, similarly AgNO3 can also combine with NaCl and forms, this is a white curdy PPT. This is also a white curdy PPT will be formed, plus NaNO3. What is this? White PPT is formed. Over here, this is also a white PPT that is formed. Take another example. Copper sulfate when treated with sodium hydroxide. Okay, so it is going to form CuOH whole twice, which is a blue PPT. It is a pale blue PPT plus Na2SO4. These are all colorless. They are all colorless substances. Okay, they are all colorless, whereas the PPTs, they are colored or maybe colorless. Another example you take, FeCl3 when treated with NH4OH. This is going to form FeOH whole thrice. This is again a PPT which is reddish brown in color, plus what is it going to give out? NH4Cl, which is again colorless. So what did we observe in this characteristic of a chemical reaction? That certain chemical reactions, they also form PPTs. What are PPTs? They are insoluble products in water they are insoluble product. Remember what the word I am using. They are insoluble products, right? Which do not dissolve in water, right? They are of different colors. How are they shown? By the downward arrow. And last part for today, that is the evolution or absorption of heat. This is also one of the basic property of a reaction, of a chemical reaction. That is the fourth one, evolution or absorption of heat. Okay, now firstly understand how do we show heat. Heat is shown with a triangle which is placed above the arrow. This is how we denote heat. Clear? So let us begin with some examples like evolution of heat. First understand evolution of heat. That is, lot of heat is given out. Such reactions are called as exothermic reactions. Okay, and absorption of heat means lot of heat is given into the reactant to proceed the reaction. They are called as endothermic reactions. So based on this, let us do certain examples. Like nitrogen combines with hydrogen. Now 3 parts of hydrogen, and on heating it gives out lots and lots of heat. It gives out lots of heat. So gives out lot of heat means plus lot of heat. What kind of a reaction is this? Evolution of lot of heat. It is an exothermic reaction. It is an exothermic reaction. Clear? Another example you take. Nitrogen combines with oxygen. Okay? And do you know how much temperature does it require? 1000 degrees Celsius it requires to form nitric oxide. Right? Over here, how can I write? Minus nothing, no heat is given out. So I write minus triangle. Means no heat is given out. In fact, to this particular reaction, 1000 temperature was given, then only the reaction proceeded. So what kind of a reaction is this? This is endothermic reaction. Got it? Another example you can take, like carbon, and when this carbon is treated with steam. Now look over here. What did I say? This carbon is treated with steam. Steam means already at higher temperature. This carbon is also red hot. Red hot means already heated at high temperature. So we are already providing such high temperature to my reactant. But the reaction still does not proceed till I do not give the temperature of 1000 degrees. Sorry, I am over here. Over here it was 3000 degrees. Okay. At 3000 degrees the reaction takes place over here. For carbon and steam it is 1000 degree Celsius. So what is it going to form? It will form a fuel gas. What is the name of this? CO plus H2, and this is called as water gas. Okay. So what kind of a reaction it should be? Such a lot of heat is given to carbon. Then water also, it is at high temperature, that is in the form of a steam. Apart from this, such kind of reactant, we need 1000 degrees Celsius to initiate the reaction. So then only my water gas is formed. So this could be represented like this. What kind of reaction is this then? Endothermic reaction. So did you understand the 4 different characteristics of the chemical reaction? What were they? That was change in the color. That is from the reactant to the product side, the color of the compound changes. Then evolution of gas. Certain reactions, they show evolution of gas. Some of the reactions you saw, the precipitate was formed. And last but not the least, there are certain reactions where either there is evolution of heat or there is absorption of heat for the reaction to proceed. I stop over here. Next time I'll come back with different conditions that are required for a chemical reaction to proceed. Today we studied just the characteristics of the chemical reaction, and next video we are going to study about certain conditions that are necessary for a chemical reaction to proceed. Thank you. आके बंद करो भाई.